See, as I was telling you, like, so what are the things I have told you in physical design? In physical design, so physical design, there are lot many things that we have to do. First thing is, so placement, sorry, for floor planning, before floor planning, partitioning, floor planning, placement, clock routing, clock tree synthesis, right? Clock tree synthesis. Then clock tree, after clock tree synthesis, so we have signal routing. So all these things we have seen. After signal routing, then timing closure. Okay. So you have to do the partitioning. So that means what different modules, analog modules, digital modules, all those modules you have to do the partitioning. You have to do the floor planning. That means in a given area you have to fix up all the modules. In such way you have to plan the. You have to plan. Next thing is placement. After floor planning, you will place all the modules in the required platform. Next, clock tree synthesis. You should make sure that the clock signal is reaching all the modules at the same time. In signal routing means power rails, power supply, VDD or VSS, all these power rails also should reach, or power supply also should reach all the modules at the same time. Okay. After doing these many things also, I told you there will be there will be an issue with the timings. Okay. So we may expect the output after giving the input. We may expect the output in 2 nanoseconds, but it is generating the output in 3 nanoseconds. Okay, so these issues will come. What is the reason for this time delay? Just now I have told you. So what is the reason for this time delay? Can you Can you tell me what might be the reason for this time delay? So I will expect the output at 2 nanoseconds. So but my output is I'm getting at 3 nanoseconds. What might be the reason? After all these things, till signal routing, I have done very much perfectly, but still I have an issue with the timing. Anyone? It's okay. Why? Because after doing all these things perfectly also, what happens means whatever the wires which are used for interconnecting all these modules. So these wires are nothing but the metals. So yeah, wire length. So these wires are nothing but the metals. These metals are having parasitic resistances and parasitic capacitances. So they both gives rise to time delay. Okay. So these time delay, time delay would reduce cheyali ante. If you want to reduce this time delay, I will go with the type of metal. It depends upon the type of metal. So aluminum is there. Okay. So copper is there, whichever it is required, whichever the metal is having less parasitics, I will prefer that metal. Sometimes gold is also used. Okay, so wherever the timing is so much crucial, gold also will be used. Small very less diameter gold wires also will be used for these things. Okay, once all these things are done, what we have to do is we have to close the timing and then again go back. If we go back to this flow chart again, Uh, if we go back to this flow chart, so after timing closure, we'll check the timing. Next, sign off. We will sign off. The physical verification will be signed off. All these things you should not think all these are the part of manufacturing till we have not come till manufacture. All these things are done. Partitioning, floor planning, placement, clock tree synthesis, signal routing, timing closure. Physical designers will take care of all these things, okay? And each floor planning is one department, placement, clock tree synthesis, signal routing, timing closure. These are all different areas, okay? So where each and every engineer, one engineer will be working on placement, the other one will be working on clock tree synthesis. So these things like this it will happen. Next one is after that physical verification, I am signing off. Timing is also very much perfect, and then I will go for layout. Okay, I will go for layout. So in layout also I need not tell you whatever the module which we have designed, whatever we are discussing about ALU, right? We have taken ALU as an example. So that ALU module we have designed, the corresponding layout should be done. Okay, the corresponding layout should be done, and then DRC, LVS, ERC checking we will do. Once after getting the layout will be in colors. Okay, the layout will be in colors. So that layout information I will be taking and I will be printing on the IC. Okay, I will be printing on the wafer. This round color one which you are seeing, this is the wafer. Okay, silicon wafer. So this silicon wafer is divided into many partitions. Maybe it depends upon the size of the diameter of the silicon wafer. Big wafer you can produce thousands of ICs at the same time, or else you can produce 10,000 of ICs at the same time. Okay, in this wafer each and every rectangular portion, the same whatever the layout image, whatever the layout is there, one layout is enough. We can print multiple ICs, we can print thousands or lakhs of ICs at the same time on the wafer. And then each rectangular portion is nothing but an IC. We will do the pinning, and then we'll do the pack again. After that pins will be added to that IC, and then again it will be packaged with ceramic or plastic or whatever may be the packaging. After packaging you will test your IC and you will tape out in the market. This is the actual procedure of ASIC design flow. Yesterday itself we have discussed, but the thing is I want you to understand more detailedly. Okay, this is one thing. And also I have one PPT for you. I have one PPT for you. It's actually very tool related. This is industry PPT. You will understand it very clearly. Till here, if you have any doubt, you can ping me. Okay, I'll just open that PPT. Till then, if you have any doubt, you can just ping me. Are you able to see the PowerPoint? Are you able to see the PowerPoint? Yes, right? Okay, right. So see here in ICs also, we have, I told you about in IC, it is an integrated circuit. So when you are designing an IC, it is nothing but ASIC. Okay, IC is nothing but your ASIC. So it is used for specific application. That's why we are calling it as application specific integrated circuit. So in IC design and manufacturing, uh, you need to know about full custom design. IC design will be either you can go with full custom design or you can go with semi custom design. Okay, so what is the difference between this full custom design and semi custom design? See, full custom, sorry, full custom design means when you are starting the ALU which we have taken, we are starting from the scratch. Scratch means every single transistor, every single cell. Okay, so every single wire. Okay, we are starting from the scratch. Everything I am taking care of. I am starting from the beginning till the end. That means till the tape out. I am what I am designing. That is nothing but full custom design. Okay, so ALU requires arithmetic units, logic units. So arithmetic units are adder, multiplier, subtractor, whatever, shifter, counter, what decoder, comparator, all these logic units also, all the gates, all these things will be there, are required to design an ALU. All these things I am designing. To design an AND gate also, I am starting from the transistors. With the transistors I am designing the AND gate. These AND gates, taking the AND gates, I am designing the adder circuit, etc., etc. From the beginning I am starting from a single transistor. If I am taking care, then it is called as full custom design. Okay, obviously to design for full custom design it will take more time. Okay, it will take more time, and also the circuit performance also will be more. Okay, so semi custom design means already X person has designed gates. Okay, already some available predefined cells are there, and gates, or gates, NAND gates, NOR gates, predefined cells are there. I'm taking the I'm taking all these pre-designed cells, and I'm connecting them together, and I'm designing my IC. That is called a semi-custom design. That means from already some people has designed some modules, I'm making use of that modules, and I'm designing my IC. That is called a semi-custom design. Okay, so semi-custom design means it obviously from the what half of the work is already done. Okay, we are taking all the instantly available modules, and we are doing our design. That is, it will take shorter time, and C performance also will not be good as full custom design. Okay, so why? Because we will be taking different ICs from the different vendors, and we are integrating them together. Okay, we are integrating them together. So we don't know, some ICs may work with some clock speed, and some modules will work with some clock speed, and some modules will work with other clocks. Everything will be varying. That's why less opportunity for performance improvement. Full custom design, from the beginning till the end, okay. That's why if you want to increase your performance, you can increase. Okay, that you can increase the performance. Why? Because you are the owner of that IC, and you know the code and everything, RTL code which you have designed. You know in which technology you have designed. Let us suppose if you want to do any modifications, and if you want to improve the performance, then you can improve. Okay, so see here, Windows, starting from Windows 98, there was Windows 2002, and later Windows 7, Windows Vista was there, Windows 7 was there, now Windows 10 was there. See, so that is what is this? That is a complete design of Microsoft. Okay, so they are the owner. They have started from the scratch and they have ended. Let us suppose in the coming year, if they want to improve the performance and if they want to add so many future features, they can add. That is what is called full custom design. But semi-custom designs, so you are what instantly available things you are taking and you are doing, then it is used for the application. But thing is, enhancement is not possible. Okay, so this is also very important, full custom versus semi custom design. Okay, so I this is actually the Cadence what I have taken it from Cadence. So these are the different tools actually. Okay, so you need not know about all the tools for what chip level for verification. When you are verifying your blocks, you will be using incisive, and when you are what doing your digital design. Okay, RTL designers they use encounter, or else DC what is there, you can either go with the Xilinx, or in Synopsys and Mentor Graphics are also some design tools are there, but in Cadence Encounter is the tool that is used for digital design. And I told you, right, analog engineers, they will go with Virtuoso for analog, like system already it will generate a circuit, but that circuit what will not give the proper output. Definitely analog design engineers, they should involve in the circuit design, they should make so many modifications in the circuit design. Okay, then they have to give it to the physical design people. So for that analog design you will be using Virtuoso, and physical design also they will be using Virtuoso tool. Okay, for custom design. Next custom if you I told you, right, if you want to start anything from the scratch, you have to that is called as full custom design. So you have to go with Virtuoso. Okay, this is in Cadence, only in Cadence. Okay, next one is so packaging. You after your design, you have to cover. You have to package your IC. So you have to package your IC. So for that also there is one software tool, Cadence SIP. And if you are designing 10 or 20 ICs, and if you want to integrate them on the PCB design also, these things are all not required. So for digital designers, Encounter tool, we will be mostly focusing on Encounter tool. These are the industry versions here. So I will be teaching you what I will be teaching you Verilog also, right? So in Verilog, actually in this Encounter tool also, I will be showing you with only Questasim. Okay, Vestasim and Xilinx. Why? Because these things I can download in my system freely, I can show you. But these are licensed tools we cannot use actually. There is no option, no option. So have anyone worked with Cadence? Do you have idea of this Cadence tool? Can anyone have worked on Cadence? Yes or no? You tell me. No, you don't have idea of Cadence. Okay, okay. Okay, fine, fine, no problem. Okay. So, yeah. So, in the semi-custom, full custom అర్థమైంది కదా అందరికి? You got the idea of semi-custom and full custom design, right? Okay. Yes. Next thing is customized design flow. Means we will start అంటే ఇదంతా reverse what is that, we will start from the transistors. Okay, so we will take NMOS, PMOS transistors, and we will do the schematic entry. We will do the simulation and then layout, physical verification we will do. And the next thing is after DRC LVS, whatever the parasitic RC extraction అని అన్నాను కదా, so parasitic extraction I will do. After extracting the parasitics, I will use any what I will take care that there will be no time delay with this parasitics, and then I will go with GDS2 అని అంటారు, దట్ ఈస్ యాక్చువల్లీ GDS-II. సో ఇక్కడ వరకు మొత్తం ప్రాసెస్ అంతా అయిపోతుంది అనమాట. ఓకే, ఇది దిస్ ఈస్ ద ఫైనల్ లేఅవుట్ ఆఫ్టర్ RC extraction. So you can see the colors in the layout. Depending upon the colors only, the IC will be fabricated. So see here, in this RC extraction, after final thing, I will convert the data into encrypted format, that is nothing but graphical data stream information interchange. GDS2 is graphical data stream information interchange. Okay, I will encrypt the data, encrypt chesina data ne I will seal, and then I will send to the fab. So here different types of tools. Cadence is nothing but it is a mix of set of tools actually. Okay, so danlo different softwares will be there, and the different softwares will be there. Virtuoso for schematic entry will be using Virtuoso editor. So simulation multimode simulator, and again layout Virtuoso layout suite is there. For verification you will be using Assura, and JDS2 format you will be using Virtuoso. This is complete ASIC design flow. Okay, complete ASIC design flow. I will give you this what PPT. I will share this PPT with you. So you will give the specifications of your whatever you want to manufacture, and RTL coding, you will write the coding, functional simulation, synthesis you will do. After the synthesis you will get the data of all the gates, simulation, DFT, design for testability. This is also DFT engineers just simply they will work on testing. Okay, testing the ICs, ante not physical IC, virtual IC. Okay, virtual IC. DFT engineers they will apply different algorithm, test algorithms untai kada. There are different test algorithms. They will apply the test algorithms, and then they will test the IC. Okay, DFT engineers are also highly paid engineers. Okay, and next testing, their role is just testing and floor planning, power planning. As I told you, we have seen power planning and that placement, you have to place all the modules. Then clock tree synthesis, I told you clock should reach all the modules, and then you will do the signal routing. Signal routing means in between all the modules you have to a module ekkada connect ayi undali, you will do the routing. And next one is DRC LVS, again one step of DRC LVS you will do here. And XRC, RC extraction, XRC is nothing but RC extraction, and you will convert the chip into GDS2. Okay, GDS2 format. Okay, so these are the different tools, incisive encounter and Assura. These are the different tools. Okay, so this is complete ASIC design flow, which is very useful one. Okay. So one is, so any doubt here? You see this one. So you see this one till here. Do you have any doubts? Even doubts unnaya? Okay, I will go to the next. Okay, I will go to the next. So schematic కొన్ని పిక్చర్స్ చూపిస్తాను. నార్మల్లీ టెక్నాలజీ సి జీపీడీకే 80, 90, 40. జీపీడీకే మీన్స్ జెనరిక్ ప్రాసెస్ డిజైన్ కిట్. సో that means it is also like a library which will consist all the all the components related to 180 nanometer technology. I told you, right, if you are designing an IC, whether you have to choose only one, restrict to only one technology, whether 180, 90 or 45. So now we are working on less than 7 nanometer technology. Idedo paatadu anamata. We are working on less than 7 nanometer, 5 nanometer, 2 nanometer technology, like that we are working. And that too, I told you, right, CMOS is more better than NMOS and PMOS. That's why CMOS is having very advantageous. That's why we are going for CMOS technology ani. So CMOS technology kante kuda powerful technologies has come into existence. You might be hearing about this FinFET, right? Okay, FinFET technology. So nowadays everywhere, if we see whatever the electronic gadgets which were fabricating since 2-3 years, this FinFET was very powerful. FinFET means it is having its own advantages. You can Google and you can search. CMOS kuda cross ayipayam anamata. Okay, now everything on FinFET technology. Why? Because it is more and more advantageous. and also what it is a very powerful technology. Okay, you can Google and see all the things. I cannot share with you. And see, like this, if you are starting your design, tool ఎలా ఉంటుంది చూపిస్తున్నాను నేను మీకు. Just this is like design environment will be like this. You will be verifying each and everything. మీరు ఏ వైర్ దగ్గర కావాలంటే ఆ వైర్ దగ్గర you can see the what voltages, or you can check all the parameters. Okay, so simulations, these many simulators you can you AC simulation you can do, DC simulation you can do, transient simulation you can do, Monte Carlo simulations are there, and for different environments what is the output, and parametric simulation is there. Okay, yeah, Ashok, you can unmute and talk. Ashok, if you are having any doubt, you can unmute. I can't hear you. Is everything, shall I go ahead? If you have any doubt, you can ask me, or else I will go ahead. Yeah, I'm sure. Not diagram, PPT. Are you able to see the PPT? PowerPoint I'm showing. In that PowerPoint, one diagram is there. One. You are not able to see diagram. It's not Virtuoso Spectre simulator like the IC is Virtuoso. If I'm moving the slides, can you see? I'm moving the. See this. What are you able to see now? Just tell me. What are you able? You're not seeing nothing. Yeah? Once I will stop sharing, and then again I will start. Okay. Yeah, full. Now I have what? I have moved the slide. Can you see? I'm scrolling the slides. ASIC flow. Are you able to see ASIC flow? Are you able to see ASIC flow? See, schematic composer features, something is there. Cadence strategy కనిపిస్తుందా? One second. ఆడియో పీపీటీ సింక్ అవ్వట్లేదా? ASIC ఫ్లో కనిపిస్తుందా చూడండి ఒకసారి. There may be some network issue అనుకో. Network, not even network issue, సింక్ అవ్వాలి కదా. Now what are you able to see? Tell me. ఇప్పుడు ఏం కనిపిస్తుంది చెప్పండి. Not showing anything. now showing. Okay, so what it is showing, Ganesh? Tell me. ASIC flow కనిపిస్తుందా? ASIC, very good. So ASIC flow, see in ASIC flow we will now use specifications to start chesi RTL coding, functional simulation, and then we'll go with synthesis, we'll go with timing simulation, and then DFT. DFT means like whatever the IC which you have prepared, you have to test your IC, you have to test the signals. DFT engineer's role is just testing. They will apply test algorithms and they will test the IC and virtual IC. Then you have to go with floor planning. ఇచ్చిన దాంట్లో అనలాగ్ మాడ్యూల్స్ ఎక్కడ, డిజిటల్ మాడ్యూల్స్ ఎక్కడ, ప్లేస్మెంట్ ఎక్కడ, రూటింగ్ ఎక్కడ, ఇంటర్ కనెక్షన్స్ ఎక్కడ, ఆల్ ది థింగ్స్ యూ నీడ్ టు డిసైడ్. Okay, and then you have to go for power planning. Power planning means giving the supply, placement, and then clock tree synthesis you have to do. Routing, you need to do the signal routing, and then DRC versus LVS means design rule check and layout versus schematic. Then you will extract the RC and then you will convert into GDS2 format. Okay, so this is about the ASIC design flow, and then it's not required actually. So GPDK means generic process design kit. Generic process design kit is nothing but the library which is having all the if 180 nanometer GPDK 180 nanometer kit is having all the components related to 180 nanometer technology only. Now 90 like that 90 and 45 GPDK kits are having all the components related to that. You should be very careful while choosing. Ante see whenever if you are following 45 nanometer technology, you should restrict to that. Okay, you should not use any other transistor from other kit. Okay, you should use all the 45 nm technology components only. Okay, so these are the, and here I told you, right? So CMOS, we have crossed the CMOS also. CMOS also has become the oldest one. Now with the technology which is trending now since 3 years or 4 years like that is FinFET. Okay, whatever the chips, okay, SOCs kani, mobile lo na mana chips kani, so all these things are being FinFET technology is being used everywhere. Okay, so why? Because many advantages, many advantages are there with FinFET technology. You can Google about the FinFET technology and you can okay, so you can Google, and if tomorrow if I'm asking you some questions on FinFET technology, you should be able to tell. You learn when in your free time, just take 5 minutes of time and learn about FinFET technology. Why? Because whatever whichever industry you go, a project ochina kuda FinFET technology paine. Next just tool చూపిస్తున్నాను నేను. So schematic composer, Virtuoso Schematic Composer. Okay, this is the platform. Normally, so you might be knowing drag and drop components lagane untadi idi same. Next thing is and analog design environment lo, so you can prati signal daggara you can see the what outputs or signal voltage levels. And so see here industry standard simulator. So we can do AC simulation, DC simulation, transient simulation, all these simulations at a time we can do. Okay, all these simulations at a time we can do, and అన్ని simulations మీరు పక్కన పెట్టి కంపేర్ చేసుకోవచ్చు. ఫర్ ఎగ్జాంపుల్ what AC DC ante you know. Okay, so AC simulation, DC transient simulation means time versus the output. Okay, time versus the output. Monte Carlo means for different, it is still showing ASIC flow. I think it is difficult with Skype. Put change in the slide. Change in the slide. All these are the different simulations. Okay, so we can spectra simulator. So we can do the parametric Monte Carlo yield analysis. Means in different environments, if we test our IC, or even different by giving different inputs, different parameters, if we are testing our IC. Okay, so it will give the Monte Carlo yield simulation. Okay, it will give the Monte Carlo yield, and we can do the analysis, like if we are changing the technology, what is happening to the output. Okay, parametric simulation means, so చూడండి ఇక్కడ, this is what నేను కర్సర్ పెట్టిన దగ్గర, that is parametric simulation. Okay, so parametric simulation దగ్గర I am changing. Okay, length of the transistor cannot be changed. Length is fixed. Okay, length is fixed. ఇప్పుడు నేను మాస్ఫెట్ లెంత్ విడ్త్ ఉంటుంది, ఛానల్ లెంత్ విడ్త్ ఉంటుంది. ఆ విడ్త్ నేను వేరీ చేస్తూ, ఐఎమ్ వేరింగ్ ద విడ్త్, అండ్ ఇఫ్ ఐఎమ్ సీయింగ్ ద చెకింగ్ ది అవుట్పుట్ ఫర్ different widths, if ఐఎమ్ చెకింగ్ ది అవుట్పుట్, సో ఇట్ విల్ చేంజ్. ఓకే, వెన్ ఐఎమ్ ట్రాన్సిస్టర్లో ఒక్క ఫీచర్ మార్చినా అవుట్పుట్ మారిపోతుంది అన్నమాట. సో not getting exactly. Ashok, can you unmute and ask your question? Okay, మీకు ఎక్కడి దాకా అర్థమైంది, ఎక్కడి దాకా అర్థం అవ్వలేదో చెప్పండి. I'm not able to listen actually. Ashok, can you unmute yourself? Can you ask me? I think he left. And how about yeah, tell me.
అక్కడ మీరు చేంజెస్ ఏం కనబడట్లేదు, విచ్ ఇస్ స్పెక్టర్ సిమ్యులేటర్ అనేది చూపిస్తుంది.
దానిలో మీకు ఏసీ, డిసి, ట్రాన్సియంట్ అట్లా కనిపిస్తున్నాయా?
ఏసీ సిమ్యులేషన్, డిసి సిమ్యులేషన్.
అయితే పక్కన ఒక బొమ్మ కనిపిస్తుందా, ఫిగర్?
అది దానిలో చేంజెస్ అంటే కనబడట్లేదు, చాలా
ఓకే ఓకే. ఇవన్నీ ఏంటిదనంటే, ఈ డాట్స్ ఏవైతే ఉన్నాయో, దీస్ ఆర్ మాంటి కార్లో సిమ్యులేషన్ అనాలిసిస్ అనమాట. ఓకే, మాంటి కార్లో ఈల్డ్ అనాలిసిస్ అంటే, హియర్ మనము అదేమంటారు, ఆఫ్టర్ ఒక ఐసీ ఫ్యాబ్రికేట్ చేసేసిన తర్వాత, ఒక ఐసీ డిజైన్ చేసిన తర్వాత దాని అవుట్పుట్స్ అన్ని మెజర్ చేస్తాం కదా. సో డిఫరెంట్ ఎన్వైరన్మెంట్స్లో, లేకపోతే డిఫరెంట్ ఇన్పుట్స్, లేకపోతే డిఫరెంట్ వేరియబుల్ లెన్స్కి, ఓకే, వేరియబుల్ పారామీటర్స్కి మనం మెజర్ చేస్తాం అనమాట. ఓకే, సో దీస్ ఆర్ మాంటి కార్లో సిమ్యులేషన్స్. ఓకే, నెక్స్ట్ వన్ ఏంటిదంటే పారామెట్రిక్ సిమ్యులేషన్. ఇప్పుడు నేను కర్సర్ కనిపిస్తుందా మీకు?
కనబడుతుంది.
కర్సర్ కనిపిస్తుందా? ఈ రెండు చూడండి, ఇవి పారామెట్రిక్ సిమ్యులేషన్స్ అనమాట. పారామెట్రిక్ సిమ్యులేషన్ అంటే ఏం లేదు, అది ఒక ట్రాన్సిస్టర్ ఉంది కదా, మీరు ఇప్పుడు ఒక టెక్నాలజీ 45 నానోమీటర్ టెక్నాలజీ తీసుకొని మీరు ఏఎల్యూ డిజైన్ చేసినప్పుడు మీకు అవుట్పుట్స్ వస్తూ ఉన్నాయి. ఓకే, యు ఆర్ గెటింగ్ ది అవుట్పుట్స్ ప్రాపర్లీ. ఇప్పుడు దాంట్లో ఉన్న ట్రాన్సిస్టర్స్కి నేను లెంత్ 45 నానోమీటర్ లెంత్ ఎప్పుడు మార్చొద్దు, లెంత్ ఈస్ ఫిక్స్డ్ ఎవ్రీవేర్. అయితే విడ్త్ ఉంటుంది కదా, విడ్త్ నేను మారుస్తున్నాను. ఓకే, సో ఆ విడ్త్ నేను డిఫరెంట్ విడ్త్స్కి నేను అవుట్పుట్స్ చూస్తే ఐఎమ్ గెటింగ్ ది అవుట్పుట్స్ లైక్ దిస్. ఓకే, ఈ ఆరెంజ్ కలరు ఒక విడ్త్, లెటర్ సపోజ్ ఒక 10 నానోమీటర్ విడ్త్కి ఇది అవుట్పుట్ అనుకోండి. 12 నానోమీటర్ విడ్త్ మారుస్తే ఇంకొక విడ్త్, దిస్ కలర్. ఈ పింక్ కలర్ది 14 నానోమీటర్ విడ్త్. అట్లా నేను విడ్త్ మారుస్తా, వేరియింగ్ విడ్త్స్, వాట్ ఈస్ హ్యాపెనింగ్, మై అవుట్పుట్ ఈస్ వేరియింగ్. అలా విడ్త్ మాత్రమే కాదు, లెంత్ అయితే మార్చొద్దు. అలా విడ్త్ మాత్రమే కాదు, ఒకవేళ మీరు ఫర్ డిఫరెంట్ రెసిస్టర్ వాల్యూస్ ఉంటాయి కదా, యూ కెన్ చేంజ్ ఎనీ పారామీటర్స్, డిఫరెంట్ సప్లై వోల్టేజెస్కి. సో యూ కెన్ చేంజ్, దిస్ ఇస్ వాట్ ఈస్ కాల్డ్ అస్ నాట్ సప్లై వోల్టేజ్, ఓన్లీ పారామీటర్స్. రెసిస్టెన్సెస్ ఉన్నా, కెపాసిటెన్సెస్ ఉన్నా, లేకపోతే విడ్త్ లెంత్ కానీ, సో వాట్ ఎవర్ ఇట్ మే బి, ఏ పారామీటర్స్ మీరు మారుస్తే వేరియింగ్ పారామీటర్స్కి తోటి డిఫరెంట్ అవుట్పుట్స్ అట్ ద సేమ్ టైమ్ యూ కెన్ సీ. ఓకే, సో దిస్ ఇస్ వాట్ ఈస్ కాల్డ్ అస్ పారామెట్రిక్ అనాలిసిస్. ఏసీడీసీ అని అంటే యూ విల్, ఈ ఏసీడీసీ అనాలిసిస్ నార్మల్గా చేస్తారు. డీసీ వోల్టేజ్, ఏసీ వోల్టేజ్ చెక్ చేసుకుంటూ ఉంటారు ఫర్ డిపెండింగ్ అపాన్ ద సర్క్యూట్. దాంట్లో ఇంకోటి ట్రాన్సియంట్ సిమ్యులేషన్ అని ఇక్కడ ఉంది కదా. ట్రాన్సియంట్ సిమ్యులేషన్ అంటే టైం వర్సెస్ అవుట్పుట్. ఓకే, టైం వర్సెస్ అవుట్పుట్ వోల్టేజ్, టైం వర్సెస్ అవుట్పుట్ కరెంట్. ఓకే, టైం వర్సెస్ ఎనీ పారామీటర్, దట్ ఈస్ నథింగ్ బట్ ట్రాన్సియంట్ అనాలిసిస్. ఓకే, సో నెక్స్ట్ వన్ ఏంటిదంటే మోంటీ కార్లో ఈల్డ్ అనాలిసిస్లో మీరు ఏం చేస్తారు అని అంటే, ఒక అదేమంటే ఆల్ పారామీటర్స్, అన్ని పారామీటర్స్ యూ విల్ బి చెకింగ్. అండ్ ఇంకోటి ఒక హౌ మెనీ ఐసీస్ అంటే మనం ఇఫ్ యూఆర్ వేరియింగ్ ఆల్ దీస్ పారామీటర్స్, హౌ మెనీ ఐసీస్ ఆర్ కమ్మింగ్ ఇన్ టు గుడ్ కేటగిరీ. ఓకే, మళ్ళీ మళ్ళీ అది హౌ మెనీ ఐసీస్ ఆర్ ఫెయిలింగ్. ఓకే, సో కొన్ని లెటర్ సపోజ్ ఇంకా మీకు ఈజీగా ఎట్లా చెప్పాలి అని అంటే, బియాండ్ అంటే ఒక 45 నానోమీటర్ టెక్నాలజీ ఉంది. సో 45 ఇంకా నేను కొంచెం సైజ్ స్ట్రింక్ చేశాను 22 నానోమీటర్కి. 22 నానోమీటర్ టెక్నాలజీలో సేమ్ డిజైన్ నేను చేశాను అనుకోండి, వాట్ ఈస్ హ్యాపెనింగ్. మళ్ళీ తర్వాత 12 నానోమీటర్లో సేమ్ డిజైన్ చేశాను, వాట్ ఈస్ హ్యాపెనింగ్. సో అలా. అండ్ ఇంకో డిఫరెంట్ ఎన్వైరన్మెంట్స్ కూడా తీసుకుంటుంది అనమాట మోంటీ కార్లో సిమ్యులేషన్. ఓకే, సో దీని గురించి నేను మీకు చెప్తాను, ఇంకొక క్లియర్ పిక్చర్ తోటి, క్లియర్ ఫిగర్స్ తోటి చూపిస్తాను మోంటీ కార్లో సిమ్యులేషన్. అయితే మనకి ఇంపార్టెంట్ ట్రాన్సియంట్, పారామెట్రిక్, DC analysis, transient, parametric is important. AC కూడా we will not go with AC simulation also. Why? Because ఇవన్నీ digital circuits కాబట్టి. Okay, so what like that we will do the corner analysis and then these are all the features actually. Okay, features, corner calculator ఇవన్నీ ఉంటాయి దాంట్లో టూల్లో అంతే. సో నెక్స్ట్ వన్ ఇస్, మీకు లేఅవుట్ ఎడిటర్ అని కనిపిస్తుందా ఇక్కడ? చూడండి, స్లైడ్ మారిందా? లేఅవుట్ ఎడిటర్ అని కనిపిస్తుందా? స్లైడ్ మారిందా లేఅవుట్ ఎడిటర్ అని? మళ్ళీ షేర్ చేస్తాను. ఓహ్, ఓకే, దిస్ ఈస్ ద లేఅవుట్ ఎడిటర్. నేను చెప్పాను కదా ఇందాక, మనము ఫ్లోర్ ప్లానింగ్, ప్లేస్మెంట్ వర్చువల్గా ఇలా చేస్తారనమాట. ఓకే, సో ఇది ఇక్కడ కనిపిస్తుంది కదా. సో సెల్ లేఅవుట్ ఎడిటర్, ఎనలాగ్ బ్లాక్ లేఅవుట్ ఎడిటర్, ఎడిట్ లేఅవుట్, ఓకే, పీ సెల్స్. సో ఇక్కడ మీకు రూటింగ్ కూడా ఇలా చేస్తాం అనమాట. దిస్ ఇస్ నథింగ్ బట్ ఫ్లోర్ ప్లానింగ్, ప్లేస్మెంట్, సో ఎవ్రీథింగ్. ఇక్కడ మధ్యలో ఉన్నవి ఏంటిదనంటే వైర్స్ విచ్ ఆర్ రూటింగ్, అంటే ఒక మాడ్యూల్కి కనెక్ట్ చేస్తున్నాయి అనమాట. నెక్స్ట్ వన్ ఇస్ లైక్ దట్. మనము సో ఇవి మళ్ళీ జూమ్ అవుట్ చేస్తే వీ కెన్ సీ లైక్ PMOS సెల్స్ ఎక్కడ ప్లేస్ చేస్తున్నాం, NMOS సెల్స్ ఎక్కడ ప్లేస్ చేస్తున్నాం, ఇన్ బిట్వీన్ ఏరియా వేర్ వాట్ వీఆర్ యూజింగ్ అండ్ ఎవ్రీథింగ్. ఓకే, సో దిస్ ఈస్ యాక్చువల్లీ ద ప్లాట్ఫామ్. Next one is design rule checking. Okay, I told you, right, there will be design rules. Okay, MOSFET ki how much is the width. Okay, physical verification ane slide kanipistundi kada andarki. So in design rule checking, so deen width enta. Okay, and we should follow exactly the design rules. Physical verification kanipistundi. Yes, it is taking time అంతే. ఓకే, ఇట్ ఈస్ టేకింగ్ సమ్ టైం. నేను ఇక్కడ స్క్రోల్ చేసిన తర్వాత కాసేపటికి వస్తుంది. ఓకే, ఫిజికల్ వెరిఫికేషన్లో దీస్ ఆర్ ది డిజైన్ రూల్స్ మా. సో యాక్చువల్లీ వన్ ట్రాన్సిస్టర్ is represented like this. It should have length and width like this. We should follow the design rules. So this is virtual, అంటే ఒక కంప్లీట్ ఐసీ డిజైన్ will be like this. Okay, so next DRC and LVS IC scroll చేశాను నేను. You can see, right? Wait, it will come. It is taking time kada. If you are able to see DRC and LVS, you click yes. You type yes, sorry. Slides are on my complete చేసేస్తాం. Yes, you can see, right? DRC and LVS. Okay, so this is ఇప్పుడు ఒక this is the inverter. 3 basic DRC checks అంటే దానిలో spacing, so enclosure and width. These are important, width and spacing. 2 wires ఉన్నాయి. So what should be the spacing between these 2 wires? And also what is that, in this one layer one more layer is enclosed, ante that may be contact cut. So what should be the spacing between these 2 layers? Okay, so if this is the schematic, this is the corresponding layout. Okay, I'm scrolling the slide now. Next, parasitic extraction. Next slide is parasitic extraction. If you are able to see, type S. లేదా అంటే సింపుల్గా స్టాప్ చేసి I will share. Yes, parasitic extraction, very good. So in parasitic extraction, see, actually, so there will be many layers. దీనిలో green is representing the diffusion, red is representing this, pink is representing the one more layer, like identity. Yellow is representing p diffusion, green is representing n diffusion, and this red color is indicating the polysilicon. Okay, got blue colors are indicating metal wires. అలా ఏంటిది, వాట్ యూ విల్ డూ, ఇలా లేయర్ బై లేయర్, ఒక లేయర్ పైన ఇంకో లేయర్ అలా పెట్టినప్పుడు ఏమవుతుంది అని అంటే డెఫినెట్లీ అదేమంటారు, డెఫినెట్లీ దెర్ విల్ బీ సమ్ డిస్టర్బెన్సెస్. లేయర్ ఓవర్లాప్ అయినప్పుడు షార్ట్ సర్క్యూట్స్ అవ్వడం అట్లా జరుగుతుంది అనమాట. సో RCLK, ఓకే, ఆల్ దీస్ థింగ్స్ విల్ బి ఎక్స్ట్రాక్టెడ్. ఇక్కడ RC చూడండి, లేయర్ పైన లేయర్ ఉన్నప్పుడు మధ్యలో ఒక ఇంటర్ కనెక్ట్ కెపాసిటెన్స్ అనేది ఫామ్ అయింది. ఓకే, సో అండ్ హియర్ ఆల్సో whenever the one layer and other layer are overlapping with each other, there will be a small capacitances are forming. These are parasitics. We should extract all these parasitics values and we have to set, okay, all these parasitics. This is parasitic extraction. చూడండి, ఇలాంటి ఇది లేఅవుట్, కంప్లీట్ లేఅవుట్. ఇలాంటి 3D లేఅవుట్, ఈ లేఅవుట్ ఉన్నప్పుడే మీరు ఏం చేస్తారు, ఈ లేఅవుట్ ఇన్ఫర్మేషన్ ఫ్యాబ్రికేషన్కి పంపించినప్పుడు, సో డిపెండింగ్ అపాన్ దిస్ కలర్స్ దే విల్ ఫ్యాబ్రికేట్ అవర్ ఐసి. Okay, so that's it for today. I hope you all understood. I have taken so much of time today. So is it what ardhamainda andariki today's class is interesting or not interesting, or you got any sorry, it is informative or not, edana నేర్చుకున్నారా లేదా, just give your feedback. I will close the session. whether you learned something today or not, or do you, if you have any doubts, you just put it in the chat. If everything is fine, we will close the session. I need feedback from you. If you are not giving feedback, I cannot go ahead. Ashok, after rejoining onwards, I understood nothing. Okay, you just go through the video once. You just go through the video once, and if you are not understanding anything, you can just let me know. And how about Ganesh? Ganesh, you learned something, right? Okay. PPT is showing something else. Yes, that is the problem. ఒకసారి ఏంటంటే మీరు మేబీ దట్ ఈస్ నెట్వర్క్ ఇష్యూ అనుకుంటా. సో ఒక్కసారి యూ కెన్ గో త్రూ ద వీడియో, రికార్డ్ అయితే అయింది వీడియో, ఒకసారి వీడియో చూడండి. అండ్ ఇఫ్ యూ ఆర్ నాట్ అండర్స్టాండింగ్ ఎనీథింగ్, యూ కెన్ పింగ్ మీ. వాట్ you can ping me, then I can communicate with you. Okay, so I'm closing the session, but tomorrow I will definitely revise. Tomorrow, what do you want the class tomorrow or not? Saturday? Yes, Ashok, you have to check with your network also. ఎందుకంటే మీరు అక్కడ అదేమంటారు సిగ్నల్స్ లేకున్నా లేదంటే వైఫైస్లో ఉన్న సంథింగ్. బట్ నో ప్రాబ్లం, యూ కెన్ గో త్రూ ద వీడియోలో అయితే బాగానే రికార్డ్ అవుతుంది అనుకుంటున్నాను నేను. సో యూ కెన్ చెక్ ద వీడియో అండ్ యూ కెన్ సీ. సో జస్ట్ టెల్ మీ, లెట్ మీ నో టుమారో యూ వాంట్ ది క్లాస్ ఆర్ Sunday I will not be taking the class, but tomorrow whether if you are joining, then I will take the class. You want 1 hour I will take tomorrow. So I will tell you the time. Maybe tomorrow we will start little early. Okay. 5:30 is okay for you tomorrow? I'll start the session at no. After 6 only. Okay. So okay, same time 6 to 7. 6 to 7 I will be taking tomorrow. Okay. So we'll have the session and we'll sign off here. Okay. Thank you. Once go through the video and revise everything.